Okay, this was the third question on your little test. Okay, first thing we've got to do is, it's obviously continuous data in a frequency table. We're talking about a histogram. Okay, and look, they give us a lot of help here. They say the 30 to 60 group had a bar of width 1.5 centimeters and height 1 centimeter. Okay. Now, find the width and height of the 70 to 80 group. Okay, now you could argue that this should say of the bar for the 70 to 80 group, but the height couldn't mean anything else other than the height of the bar. So, we talk about class width, okay, but the class width gets scaled. So this has got a class width of, so the class width of that is a particular number, but on the histogram we've got a width of 1.5 centimeters. So therefore you've got a correspondence between how many units wide this is, the gap between 30 and 60, which is 30. Okay, so 30 as a class width is 1.5 centimeters. Okay, so class width is 30. The width of the histogram bar is 1.5 centimeters. Okay, so you need to then scale that. So this class width is not 30, it's less. Okay, so the width of this histogram bar is going to be less as well. Alright, so that's the width, and that should be one very easy mark. Then the height of this bar was 1. Okay, but remember, heights don't show frequencies. What shows the frequency, or what's proportional to frequency, is area. So this bar has an area of some particular number of square centimeters for a frequency of, well, the frequency of 30 to 60 is 17 people. No, 36 is 10 people, sorry. Okay, so you know what area we need for a frequency of 10. The 70 to 80 group you're looking for has got a bigger frequency. It's got a frequency of 25. So you need to say the area for f equals 25. Well, we know what the area was. This area was when f equals 10. So you need to multiply up the area suitably to get the area you need for this f. And once you know the area and you know the width of the histogram bar, you can get the height of the histogram bar. Okay, so that should not be bad for 3 marks. Make sure you can do that question. Linear interpolation for the median. Actually, encouragingly, most people did that pretty well. So remember, what you've got to do is you've got to work out, we've got 85 customers. Yeah, some people got the wrong position for the median. What we need to do is do 85 divided by 2, so that's the position of the median. If you really want to, you can do that thing where you add 1, but I don't particularly, you don't need to. In fact, it's, in my view, wrong, but never mind. It doesn't matter. If you add 1 and then divide by 2, or you just divide by 2, either of those will work as your position for the median. Okay, so you need to work out in which group that comes. Okay, so the position for the median is going to be 42.5. Alright, so if you add these up till you get up to 42.5, the group which takes you beyond 42.5, and I think it is this one, okay, is the group the median is going to be in. And then you have to find out how far through that group. And some of you have got that formula where you say it's kind of the lower boundary plus, what do you say, the distance through over the class width. Okay, times the class frequency. Okay, if you want to, you can do it that way if you want to. All right, okay, but make sure you can get the correct answer for the median. Okay, then all right, x is the midpoint of each group, and they tell us these things here. So all we've got to do is to get the mean and the standard deviation from this. We've got a formula for the mean, okay, which you need to have learned, but it's got the sigma fx on the top of it. Sorry, not f of x, sigma f times x on the top. Okay, and it's got something on the bottom, and you do a division and you get a mark. Okay, and then but you do not round that off too much. You get an estimate. This is at least 3 significant figures, but you save your exact value, because if you use a rounded value for the standard deviation, you're probably going to get it wrong. And the standard deviation has got something with what they insist on calling fx squared. Okay, divided by something minus something squared. Don't forget that. Do not round off what you're using in this bracket, and you get an answer for the variance, and then you don't forget to square root it. Okay, the mark scheme quite likes, actually, if you put the square root sign on the beginning and call it the standard deviation throughout. But you're not going to get very much if you, well, you're going to get a 0 if you forget the square root. Okay, and then finally, all right, you've still got method marks here, even if you've mucked it up. We need to do mean minus median times 3 divided by the standard deviation, okay, and get an answer. All right, so if you've done all of this correctly, the first mark or so is going to be for very, very easy. And then once you've got the value for this, we're commenting on skewness, so all you're going to comment on is whether it's symmetrical or there's positive skew or negative skew. And it's a stupid mark scheme on this, because although the answer you should get, if you don't muck it up, is really quite close to naught, if it is close to naught, it's dubious whether you get a mark for saying symmetrical. You have to say nearly symmetrical. Alright, whereas they give you the mark for just saying positive or negative, even if it's really close to 0, so the amount of skew is negligible. But that's mark schemes for you. Okay, so you comment on whether it's positive, negative or 0, or you can have a mark if it's close to 0 for suitably commenting on what it means if it's close to 0. But the three things that you've got really that you could say are positive skew, negative skew, or close to symmetrical. So pick one of those in accordance with the answer you've got. Okay, alright, and next time you do this question, then can we have full marks please, because it's not hard.